So last time we'll be talking about how to basically divide, and we'll be talking about shift registers, and then we introduce the um, flip-flop toggle. Well, we have already been talking about the flip-flop toggle, but we talked about the flip-flop toggle as basically a divide by n element in which we basically got a clock as an input, and we were actually able to divide it by 2, by 4, by 8, and so on and so forth. And I know you may be wondering, why do we need to divide the clock? What is it good for? Well, it's actually useful for many different reasons, but one of the application that I can talk about is that we have any kind of stuff, but one of the things I actually thinking about is exactly the whenever you wear a clock, especially in the old time, when you had a simple clock, the easiest way to make a clock using digital circuits, like I'm not talking about clock, I'm just talking about a watch. Whenever you wear a watch, like the old-fashioned ones. Sadly, I don't have it right now because it's charging. But I wanted to show you. But anyway, so whenever you have that, what you can do is that you may have different element, different things in a circuit. One of the things you may have is this crystal, which is essentially something like this. And the frequency of this is 32,768 hertz. And it's a crystal. Now, what you can actually do is that you can say, okay, the 32,768 is actually 2 to the power of 15. So I can actually divide this by 32,768 and get 1 hertz. So basically I can get a clock of 1 hertz. So for instance, if I use flip-flop toggles and I chain them together, I can divide this and get 1 hertz. So I can basically get something to do, a circuit to do something every second, which is, kinda slow, but it's perfectly fine for, clocks. So if you have a clock, you're basically gonna do this and this and this and this and this all the way round till it gets to 60 seconds, and then the minute goes on and on and on and on again. So that's perfect for a clock. So if it happens to have clocks like, whoops, can I get this? Like the old ones, like this one, for instance, then I'm pretty sure then they use this kind of combinational logic, because it's basically, well, they can do that with other kind of flip-flops as well, but essentially it's fine. I mean, I'm pretty sure that those are made with these kind of flip-flops. So yeah, whenever you take a look at your clock, just think that you need to get 1 hertz. So there is probably there are some flip-flops in it, and they work with as a divide by n element. So yeah, that's one useful thing about flip-flop toggle. So maybe you knew, now you know.